everybody have this handout from yesterday? And I think this was the example we were getting ready for. Is that right? So, we had just finished talking about the rational zeros theorem, which told us everything that could be a zero. And you know, like, we're going to use our graphing calculator to kind of narrow down that list to save us some time. If I just made you guess and check, if you took your list of possible zeros, how do you check them to see if they work? Yep, plug them in, see if you get out 0. Reduce synthetic and see if you get a remainder of 0. Okay, so I will ask you on any of these to actually give all the zeros, so make sure you can make this list. So we start with our P's and Q's. Where do we get the P values? The last one. So what's everything that goes into 8 evenly? And I do want the plus and minus on every one of these. I don't care what order you write them in. So if you're one of those people that you think 1 and 8, 2 and 4, and write them like that, it doesn't matter to me, as long as you have them all. Q, everything that goes into the leading coefficients, everything that goes into 15. 3, 5, 15. All right, so then possible zeros, P over Q. Again, it might be annoying, but you have to put the plus and minus on all of them. So 1 over 1 is 1. 1 over 3. 1 over 5. 1 over 15. 2 over 1 is 2. 2 over 3. 2 over 5. 2 over 15. All right, 4 over 1 is 4. 4 thirds. 4 fifths. 4 15ths. And finally 8. So 8 over 1 is 8. 8 thirds. 8 fifths. And 8 15ths. I kind of did this one on purpose to show you how many possible zeros we can get. I just want you to recognize most of these problems, I'm picking pretty nice ones, so you have a very short list of possible zeros, but the list could easily be very long. You know, if I think about if I gave you like 40 as your constant, everything that goes into 40, 1 and 40, 2 and 10, you know, and 2 and 10. How about 2 and 20, 4 and 10, 5 and 8? You know, so we could have a list that had a lot of possible zeros. I'm going to pick fairly nice ones, but just recognize that they don't have to be that nice. When we're using our calculator, it's not always possible, but whenever possible to look for a zero, try to get a whole number or an integer zero. Try to avoid those fractions if you can. Sometimes all the zeros are fractions and we can't avoid it. But in general, our synthetic division and the factoring that follows is going to be nicer if we have an integer value for our zero. So this should have been the process you guys did on problem 36 last night, the very last one. So now we graph the original, and we are looking for an x-intercept, where it hits the x-axis. How many of them should there be? 3. And how do we know that? X to the third. So we should have 3 possible ones. We just need to get one of those. What do you think? Can you tell? So we just need one of the starting ones. Can you tell anything? -4. Okay, and if you weren't sure if it hit on -4, how can you quickly check that? Yeah, plug it in for x and see if you get out 0. All right, so once we have one of these, Then we do our synthetic division. 15 comes down. Negative 60 adds to 1. So then this breaks down to 15x squared plus x minus 2. And this is pretty good news for us because what can we do now? Flip and slide, factor that. Okay, so x squared plus x minus 30. So what multiplies to negative 30 and adds to positive 1? And on our last quiz, what did most of you forget to do after this? Okay. So 5 over 15 reduces to 1/3, so that would be a 3x minus 1. 6 over 15 reduces to 2/5, so that's 5x plus 2. All right, this one asks for the factored form and the zeros. Factored form. When it comes time to a test, I'm going to ask for both of these things, and you better know which is which. Factored form has all the factors in it, has the x's. What am I missing? The third one. Since negative 4 worked, we always do the opposite, so it would be x plus 4. And the zeros are just the numbers, the x-intercepts. So what makes 3x minus 1 equal 0? What about 5x plus 2? And x plus 4? Were all of those numbers on my list of possible zeros to start with?
Yes.
Yes.
Jalen said that she thinks we put the stats video in college algebra, so she doesn't have the right video.
All right. Is this one okay? You did find a good video? Okay, for today I put it. All right. Hello. Yes. Okay. Bye. Here, can you go to the office for that? Okay, so let's do one more. This one's going to be slightly different. So I'm asking for the real zeros. Do you recognize how this one's different than the others we've been doing?
It has an extra x.
Yeah, it's next to the fourth. So we should get how many zeros? 4. Okay. Process starts out the same. P's, Q's, possible zeros. So what are my P values? 1 and 2, because the P comes from the constant. Q comes from the leading coefficient. So what would those be? So the possible. That's P over Q. So 1 over 1 is 1. 1/2. 1/3. 1/6. Do you guys see where I'm getting these numbers? 2 over 1 is 2. 2 over 2 is 1. I already have it on my list. 2 over 3. 2 over 6 is 1/3, and I've got that. So now, what do we do? Plug it in, graph it. Let's see what is an x-intercept. So can you tell something that works? 1. And if you started with a different one, that's okay. We just have to have one of them that is. So then we do our synthetic with that number. So at the end of this, my remainder constant x squared, this is still an x cubed. Are we ready to do box method yet? No. But we already have a list of everything that could be a 0. Okay, if it's a 0 of the original, it's still a 0 of this. So we just need another one. So you can, just graph this and look for an x-intercept, or we could look at the graph that we're already holding in our hand. What else works? Where else do we hit the x-axis? -2. So we could do the synthetic again with -2, and the answer we just got out. We could find all of our zeros this way, but it's not the most efficient because when we start getting fractions, it's a little bit harder to tell. We're also going to talk about how sometimes we might have imaginary zeros. Didn't we have one yesterday where we had the first 0 and then we had to do quadratic formula and get an imaginary? And can you tell those imaginary zeros from the graph? No. So we can't get everything from the graph, but as soon as I get down to this point, what could I easily do? Yep. So let's do a slip and slide and factor this. So, multiply -6 and add to +1 would be +3 -2. But then I need to divide by 6. So 3/6 reduces to 1/2. So that's 2x plus 1. 2/6 reduces to 1/3. So that's 3x minus 1. My factored form, how many are we expecting? 4. So what else do I need in here? Right, we have to put a parenthesis for each of those zeros we already divided. So we have an x minus 1 and an x plus 2.
John?
Alright, so my zeros, so each of these parentheses equal to 0, and we get so a little bit time consuming, but we just factored a 4th power polynomial. Alright. I have a couple more on here. Let's do, I want to do at least one more. I want to do the 5th power one on my next slide. Okay, and then if you guys are confident, we can skip the next example. That'll be up to you guys after this one.
Let's go.
Okay. So, where do we start? P's, Q's, and possible zeros. So my P value comes from 48. Okay. 48. That is beautiful.
Yes, sir. I love it.
All right. What goes into 48? 6,
1.
What's this?
1, 2.
All right, we have 1 and 48, 2 and 24, 3 and 16, 4 and 12, and
6 and 8.
6 and 8. All right, I didn't put them in order this time, but we got them all.
Wait, can you second
It's a lot of numbers. Sorry, you might need an extra sheet of paper on this one if you don't write small.
That could be a problem.
Could be a problem, huh? You don't have any paper?
No, I was writing small as numbers.
Oh, fair enough.
It's my thing. No, it's not. It's not.
Okay, what are my Q values?
1.
Yeah, this is a coefficient of 1, so my only Q values are plus and minus 1.
Wait,
So,
all that.
yes, so my possible zeros, P over Q, it's each of these numbers over 1. Can I just draw an arrow and say it's all of those values?
Nope, write it out.
Okay, Waylon's gonna write it out. We'll give him a second.
Give me
If
both.
I even done writing my curse ones down.
Yes, I am. He's lying.
Okay, so how many am I gonna have this time that work?
A bunch.
5. A bunch. Okay, let's find one.
Okay.
So graph it. And everybody knows when you graph it what you're looking for. So we're trying to find where it hits the x-axis.
I'm saying it.
-3, I agree with that.
-3, we're pretty confident in that one, not really sure about the rest.
I bet Waylon's sold.
So it's very kind of you. Alright, so you're getting a graph that looks something like this, right? From what you can see.
Yes.
Best guess. Okay, so we think -3 works. Let's try it. So what power is this currently? That's to the 4th power. So we're still trying to break this thing down. Looking at my graph, where else does it hit the axis? At 2. It kind of hits it and bounces off, but that still counts. So we're going to do synthetic again with a 2 this time. And the answer we just got out.
Oh, we have to do this 3 times, don't we?
Yeah. Yep, it hit the x-axis at 2. Okay. Now what?
Wait, what are those numbers?
Hmm? You could. That would work. So just something about graphs that we're going to be talking about. You notice how at 2 it looks a little bit different because it bounces off? That's actually caused when 2 is a 0 multiple times. So when it bounces like that, real quick check. If you plug a 2 into this, what are you going to get out? 0. Lucky guess, huh? So when you are looking at your graph and it bounces, that means 2 is a 0 more than once. So we can divide it by 2 one more time. So I'm going to do 2 again, and the answer we just got out. How do I write this polynomial for my final answer? What is
X squared plus 4.
x squared plus 4? Okay. Can I do box method with that? No. Can I do difference of squares? No. So we don't really know what to do here. Okay, so currently, what zeros do we have so far? Which numbers were a 0? The actual zeros that worked, we have -3, and 2. Okay. So currently my zeros are -3, 2. Since it worked twice, we call that a multiplicity. So we put an M and then a 2 with it. That means 2 was an answer 2 times rather than listing it twice on my list. So I currently have 3 of my 5 total zeros. If you want the other one, what if we set this equal to 0? What would you do? When you add a square root, you do plus and minus. What is the square root of -4? 2i. We can't tell those imaginaries from the graph. But those are the final 2 zeros, positive and -2i. My 5 zeros. So the factored form. If -3 was a 0, what would my factor be? If 2 is a 0. That multiplicity 2 means it showed up twice, so we put a square on it. All right, plus and minus 2i, let's treat those separately. So if 2i is a 0, what would we put? And if -2i is a 0, and that is my factored form. All right, so we did one that had a repeated 0, it had imaginary zeros, so we've kind of covered all of our bases here. Do we need another example like that? Okay. So the last little bit that I want to talk about today fundamental theorem of algebra just tells us if you have a polynomial with a degree 1 or higher, it has at least one complex 0. Basically, every number, real and imaginary, that's part of a complex number. So this just tells us we have zeros. The next piece we've already mentioned, the degree tells you how many zeros you're going to have. They might all be real numbers. Some might be real, some might be imaginary. Okay, so if it's a degree 5, I would have at most 5 real zeros. We will have 5 total, but some of them could be imaginary. Multiplicity, like we already said, is the number of times it occurs. So this factors into x plus 1 cubed. So my 0 would be -1. What would be the multiplicity there? 3. So you could have a repeated 0. That's just a multiplicity. All right, so quick question. How many real zeros can this function have? 5. It will have 5 exactly, but some could be real, some could be imaginary. All right. We're going to do one more slide and then we're stopping for today. Okay? So, I want to create a polynomial to meet these requirements. My zeros are -3. If -3 is a 0, what do I have in my polynomial? If -2 is a 0, what do I have in my polynomial? If 5 is a 0. Okay, so I've taken care of this. Here's my other requirement. What does that tell me? Right, when I plug in -1, I have to get 6 out. Now I can't have any other zeros, but what I could have is a number out in front. This could all be like ×2 or 3 or something like that. So, let's figure out what this number has to be. So if I plug in -1, -1 plus 3 is 2. -1 plus 2, -1 minus 5, and that has to equal 6. Everybody understand that part? So we get -12a equals 6. Divide by -12, so a is -1/2. So my final polynomial, we have -1/2 x plus 3, x plus 2, x minus 5. I am not going to ask you to multiply that all out. Okay, we can just leave it like this. Just know there's some of these on your homework. The answers in the back of the book are all multiplied out. You don't need to do that. You can leave it in factor form. All right, last problem for today. 4 is a 0 of multiplicity 3. What does that mean? And f of 2 equals -24. So what do I need? There could be an a out in front. Let's figure out what a is. So if I plug in a 2 for my x, 2 minus 4 is -2 cubed. So -8a equals -24. Divide and we get 3. So my polynomial is 3 times x minus 4 to the 3rd. Is this okay with everybody? Okay, so for homework, I have homework printed on here. We did not do one last night. I kind of shortened last night, so I'm going to add it on tonight. We have over 20 minutes right now to work on this. So I want you to do 37 through 39, and then 44